Hello, welcome to the series of linear integrated circuit, and we are going to discuss about subtractor op-amp. Basically, this is a kind of differential amplifier because we have input at both of the terminal, inverting terminal as well as non-inverting terminal. Means these voltages are connected both of the input terminal of operational amplifier. So we can say this is a kind of differential amplifier. So in previous lectures, we had discussed inverting amplifier, non-inverting amplifier, summing amplifier also. In inverting amplifier, we can connect our input signal only at inverting terminal. In non-inverting amplifier, we are connecting our input signal only at non-inverting terminal. The inverting terminal should be grounded. And in differential amplifier, we are connecting signals in both of the terminals. So here we have V1 and V2 that are connected at inverting and non-inverting. So this is a kind of differential amplifier. So we will discuss this circuit that can work as a subtractor also. So we can write here that this is a kind of differential differential amplifier. This is a kind of differential amplifier. Differential amplifier. The we can write here inputs are connected. Inputs are connected at both the op-amp input terminals. So we will analyze this circuit, and subtractor will provide us. This can provide us the difference of it. Will provide the difference. It will provide the difference between voltages. Difference between voltages. What voltages that are connected at both of the terminals. So first we will make it circuit diagram. Then we will analyze that how can we get the output of the circuit. So here we have the op-amp symbol. ये हमने op-amp symbol बना दिया. We are getting output from here. This is the output. This is inverting terminal, non-inverting terminal. We have two DC supply. Let's say this is plus VCC. This one is minus VCC. And these are the two terminals. We will connect a feedback resistance here. So this is the feedback resistance RF. And this is V2. This one is V1. This was V1. So the difference between these two voltages is VID, that is V1 minus V2. So now we will connect resistances with voltage also. So here we have R1. This is R1 resistance and one voltage source, that is VA. This is plus, this terminal is minus. We have connected a VA source here with a series resistance R1, and in non-inverting terminal we can connect here one resistance R3. Let's say this is R3. This one is R4, and voltage is connected with this R3 resistance. Here this voltage is, let's say, plus minus, let's say this is VB. So this becomes the circuit diagram for subtractor. Now we are going to analyze this circuit, and there are two methods to analyze this one. One is by considering any one voltage source at a time. Basically we can apply superposition theorem. if we have multiple voltage sources, so one at a time we can consider and the rest voltage sources should be count. Suppose हमने इस VA को consider किया, then we will take VB as 0, that VB is short circuited, VB as 0, and if we are considering this VB, then we will take this VA as 0, and in both of the situation we will get the output, and the sum of that output will provide the net output of this circuit. This is the first method. And second method we can utilize here, we will find out the voltage at this point, at this V1 voltage, and whatever voltage V1 will have, that will be automatically reflected to inverting terminal, means here at V2. So by using that concept we can get the final output. So first we will analyze it by superposition theorem. So by superposition theorem, let's say consider, here we are writing here, consider VB as 0. So whatever output we will get, that is known as V output 1. So here we have only VA connected at this circuit. So we can short this circuit as, we can modify this circuit as, now we have V output 1. This is the superposition theorem. And here we have this R3, this is R4, let's say this is R3, this one is R4, and this voltage is grounded, VB is 0. So basically there is no voltage, and we have R1, this one is R1, and here a feedback resistance is connected as RF, and we have applied here a voltage, that is VA, and this is grounded. So we have analyzed this, become the inverting amplifier. This is simply inverting amplifier where we have feedback resistance RF and resistance connected at inverting terminal as R1. So what will be the output? Output will be simply minus RF divided by R1 into input voltage VA. So this is equation number 1. Now consider as VA, now consider as VA is equal to 0. This is the circuit when VB becomes 0. Now we can make a diagram here, make a circuit here considering VA as 0. So this VA becomes 0. So this is the R1, this is R1, and we have a feedback resistance, that is RF, and here this is the, let's say, output 2. When VA is equal to 0, then we will get output as output 2, and we have R3, this one is R4, this is R3, and voltage here is, this is VB, this is VB. So for this we will get the output as, let's say this is V1, we will get the output 2 as, we have analyzed non-inverting amplifier previous, we have seen the output as 1 plus RF upon R1 into V1 into V1. Now we have to find out the value of this V1. This is the V1, and this value will be the value that will be here at this non-inverting terminal. So what will be the value of V1 that we need to find out? So for this we have to analyze the voltage divider rule. We must know the voltage divider rule. So first we will understand it, that what is the voltage divider rule. We can consider this particular circuit here in a separate way. So this is basically, we are going to analyze this circuit. So we can make the circuit as, this is R3, this one is R4, and this voltage is VB, and we want to find out voltage at this point, that is V2. So V2 is voltage across R4 resistance. Voltage across R4 resistance. So here the current flowing in each branch, we can write the current flowing in each branch, like this is the current, that is I. So we can write I as VB divided by R3 plus R4, voltage source divided by total resistance of that circuit. So voltage voltage across this R4 resistance, voltage across R4 resistance is basically V2. So this will become simply in I into R4. So that become VB divided by R3 plus R4 into R4. So we can put this value in equation number, this equation, let's say this equation number 2. So here we can write, equation 2 will become as, equation 2 will be as V output 2 is equal to, this is 1 plus RF upon R1 into V1, 1 plus RF upon R1 into V1. So this voltage is basically, this voltage is V1. This we can write as V1. This voltage is V1. So this is V1. So here we can write 1 plus RF upon R1 into V1. So V1 value is, V1 is this term, that is VB into R4 divided by R1 divided by, what is divided by? Divided by R3 plus R4. So we can write R3 plus R4. So final output, considering both of the sources, can be written as the final output. Final output can be written as V output is equal to V output 1 plus V output 2. So this is equation number 3. So what is V output 1? V output 1 is this one, minus RF upon R1 into VA. What is V output 2? V output is this one. So we can write minus RF upon R1 into VA plus 1 plus RF upon R1 into VB into R4 divided by R3 plus R4 divided by R3 plus R4. So now we can simplify it, considering some cases. So here, let's say here, consider all resistances are equal, means RF is equal to R1 is equal to R3 is equal to R4. Let's say these all are resistance R. So what will happen? This will become minus VA. This will become minus VA because this term will become minus 1 plus this is 1. This is RF upon R1. So this become 1 plus 1 into VB. Here it is R. This is R divided by R plus R. So this become VB divided by 2. So this 2 and 2 both will be the cancel out. So what will be the output? The output we can write here. The output is simply VB minus VA. This will be VB minus VA. So this is the final output. So we can say that the output is simply the subtracted value. This is the difference of voltage applied at non-inverting terminal minus voltage applied at inverting terminal. This is applied input voltage at inverting terminal, and this is applied voltage at non-inverting terminal. So in this way, by using superposition theorem, we can analyze this circuit. And there is one other method also. So we can say this is the method 1. This is basically, this is method 1, by using superposition theorem. This is by using superposition theorem. And next one is simply by using the concept of virtual ground concept. Next is by using virtual ground concept. So according to this, what we can say, we have this circuit, so we can write here V output. We want to find out V output. So see, we will make circuit here again. Let's say this is the circuit, that is minus plus. We have this output. This one is R1. Here voltage applied at VA, and this is non-inverting terminal. We have R4. This is R3. This is the voltage, that is VB. And we have a feedback resistance RF. So simply, first at the junction, we will see here, this is the junction. This is, let's say, point node A. So here we have current I1. Let's say this is I1. Inside going current is, let's say, I3. And this current is, let's say, IF. So at node A, we can write at node A, apply Kirchhoff current law, apply KVL. So this will become I1 is equal to I3 plus IF. Since we have infinite input resistance, so this I3 will become 0. So what can we write I1? I1 is simply VA minus V2. The point voltage here at 8 node is V2. Here this is V1. VA minus V2 divided by R1 is equal to V2 minus V output divided by, this is RF. So here what is V1? V1 is basically VB into R4 divided by R3 plus R4, that we have seen earlier by using voltage division rule. So V2 will also be equal to V1 by virtual ground concept. So we can put this V2 as V1 here. So this equation implies VA minus, what is the V2? VB into R4 divided by R3 plus R4 whole divided by R1 is equal to V2. What is V2? V2 is simply VB into R4 divided by R3 plus R4 minus V output divided by RF. So again we will apply the similar condition. That what was the condition? That is R1 is equal to RF is equal to R3 is equal to R4. These all are equal to R. So if we will apply this condition, so from this equation, let's say this equation is 1. So from equation 1, we will get V output as we output as VB minus VA. Again, the difference of the voltage applied at inverting and non-inverting terminal. So this is simple circuit of subtractor, that is a kind of differential amplifier. So hope you have understood it. So this is all about subtractor. Thank you for watching, and in next video we will see some numerical based on subtractor and other circuits of integrator and differentiator, that are the linear applications of op-amp.